Welcome everyone. Today we're repairing a General Electric refrigerator's light power supply module. White and black wires are the primary winding. We check the resistance. The reading is 10 ohms, which is normal. Next is the secondary winding. There is a DC rectifier with a single capacitor. The simplest circuit. There should be DC voltage on these two wires. There's a marking, plus and minus. Let's check the secondary winding. Here is a fuse installed inside. We check it. It's a very simple circuit, but an unusual problem. The fuse is okay, so there should be continuity of the transformer's secondary step-down winding at this connector. We place one probe here. There is good access to the contacts. The second goes here and surprise! No continuity on the secondary winding. Let's check again from here through the fuse. And we see that voltage passes. Conclusion: the issue lies in the transformer's secondary winding. There's a label on the transformer. On the input side, there are 120 V white and black wires. These two receive the primary winding voltage. Voltage is measured between the two black wires, and there should be 27 VAC from the secondary winding. Let's take it apart, remove the insulation tape from the transformer, and take a look. It'll be interesting to see what happens. Perhaps a thermal protector was installed. The thermal fuse is mainly installed on the primary winding, maybe here on the secondary. Now I'll try to cut the insulation tape out and see how the wires are connected to the winding. Let's look. So here's the transformer. Two black wires. You can see some winding over there. Indeed, there is some protection component, either overload or overheat protection. An additional fuse was installed right here in this circuit, and on this side it's marked that it should be no more than 3 amps. We know that it's okay. Let's do one more check just in case, with the transformer removed. Here we have one wire. Here's the second wire. We confirm that there is no continuity in the circuit. Let's try to cut through the insulation tape and see what's in there waiting for us. I've disassembled it slightly. Here we have a paper insulation pad. Let's move it aside. And now we see that a hidden component is installed here. We are getting to it. So, this one is clearly a wire soldered directly to this black one. And here the second one goes through thermal or current-based protection. Let's see if we can reach it. Okay, slowly. There's another layer of insulation here. Something is already visible in the depth there. So now we see here. This is what I was looking for. Here we have a hidden fuse. Well then, there's a chance that we can still fix it. Let's see what this component is. After examining this part in detail, I found no temperature ratings, only amperage. It appears to be a standard fuse of 3.15 amps. And since we have an additional secondary fuse right here in the circuit break, which is installed on the power supply housing, we'll leave it. I plan to remove this fuse and solder the wire directly here. Reassemble and test if it works under load for at least 30 minutes without the transformer overheating. We conclude the fuse failed. Why, God knows. I'll check the secondary fuse later. Maybe the wrong amperage was installed, causing this one to fail. Moving on. I'm not aiming for aesthetics. Don't judge our work too harshly. Our goal is just to bring it back to life. It should work. Close it back up with cardboard. Here's what we ended up with. There may not be any beauty, but the functionality should be there. Well then, let's assemble and test. We screw the transformer back in carefully. Done. We reconnect the terminals. This one goes here. This goes here. The secondary winding connector goes right here. Let's check if we have the output DC voltage and we'll try to apply a load. We move on. Okay, everything is assembled. 120V is applied directly to white and black wires. Let's check if we have AC voltage on the connector. We have 30 VAC and that already looks not bad. Let's check DC on the output. Here are two wires. Let's see, and we have 40 VDC here without load. Okay, now we test under load. I had to come up with something since I didn't have anything suitable for this project. For the load, we'll use a standard 150W light bulb on 120V. This power supply unit will be used with lamps like this one, but the voltage and power will be different. Our task is to test under load. Let's check what we get. We see the lamp lights up. Aha, we see it. So the current reading is approximately 0.7 amps at 40V, roughly around 30W on a 50W transformer. I don't think it will be loaded more than this. Under such a load, I'll leave it for at least 30 minutes since, in the refrigerator, it only loads when the door is open. As soon as we close the door, the light goes off and the load is removed. So a half-hour test is more than enough. I'll run it off camera and that's going to be it. Alright, so after about 25 minutes under load, let's check the temperature. Let's measure the lamp's temperature, which is pretty high. Now let's check the transformer's temperature. It's around 86-87 degrees Fahrenheit, and on the winding, about 90-93 degrees Fahrenheit. It looks like everything works properly. If there is an inter-winding short circuit for the transformer, it would be extremely hot. It seems like it will work. That's it. The repair is done and it's ready to install. It should last for a long time. Alright, let's check the protective fuse that remains in the circuit. We see that the fuse is rated at 3 amps. We are good to go. That's it now.